So in this video, we're going to talk about the cross product. Alright, so the reason we care about the cross product in this course, or the cross product between two vectors in this course, is we need a better way to calculate the moment about a point if we have a 3D problem where we have our position our moment arm and our force are defined in 3 dimensions. So what we're going to be talking about here is the cross product between two vectors A and B would be equal to a third vector, vector C. All right. So for the cross product, we define the magnitude of the cross product as being equal to the magnitude of vector A times the magnitude of vector B times the sine of theta, which is theta is the angle between A and B. All right. So for the direction, all right, how does the direction C relate to the vectors A and B? All right. So we can think of vector C we can define as being equal to the magnitude of vector A again times the magnitude of vector B times sine theta times the unit vector of vector C. Now the unit vector of vector C is going to be perpendicular with A and vector A and vector B. Okay, so all right, so for our so how this typically would rule you could determine vector C using the right hand rule. So in this case, vector B would represent you would put your fingers along vector B. Vector A would be associated with your palm of your hand, and then vector C would be associated with your thumb. All right. So for the cross product, there's a few things in terms of how you can apply the cross product that you should be aware of. So for example, the commutative property, which basically says that does the order at which you do the operation matter? So that does not apply for the cross product. So A cross B, for example, does not equal B cross A, but A cross B does equal negative B cross A. So when you're keeping in mind, if you're supposed to do a cross product in a certain fashion, you must do it in that fashion. Otherwise, you're going to get the negative answer. So then the second property is the associative property, which basically means if you multiply a cross product by a scalar, it doesn't matter if you do it after the cross product or before. It doesn't matter what order that you apply it. And then the distributive property states that A cross B, A cross the sum of B and vectors B and D would be the same as taking the cross product of A and B, the cross product of A and D, and then adding their resultant together. All right.